Welcome to our first day of Chapter 10 notes. In Chapter 10, we're going to be learning about conic sections. Conic sections are circles, parabolas, ellipses, and hyperbolas. But before we learn about conic sections, we need to know how to use the distance and midpoint formulas. These are formulas that we have used before. Our objectives are to find the midpoint of a segment using the midpoint formula, and to find the distance between 2 points using the distance formula. We are looking at 2 points on a coordinate plane, so I would like to show you a diagram of that. So if I move over to the right a little bit, if I quickly sketch an XY axis and draw 2 points and a line segment between those points, I have endpoints P and Q, and we will be able to find the coordinates of the midpoint and also the distance between P and Q. So let's go back over and find those formulas. Now I'm going to call point x1, y1, those coordinates, point P, and the point with coordinates x2, y2, point Q. The midpoint formula, I use a subscript m to represent the x-coordinate of the midpoint, and the y-coordinate of the midpoint also has the subscript m. That equals x1 plus x2 divided by 2. That will give us the coordinate of our midpoint, the x-coordinate. Our y-coordinate is y1 plus y2 divided by 2. The distance formula is d, distance, equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to be using those two formulas in our examples at the bottom of the page, first to find the midpoint and then to find distance. So in example 1, we want to use the midpoint formula to find the midpoint of the line segment with endpoints at the given coordinates. So let's make this a little bit larger. So we want to find our x-coordinate of our midpoint and our y-coordinate of our midpoint. So we add x1 plus x2 and divide by 2. And then we add y1 plus y2 and divide by 2. We then calculate want to calculate our values. 5.4 plus 9.2 is 14.6 divided by 2. Negative 8 plus 10 is 2 divided by 2. And then we can simplify those, and our coordinates for our midpoint are 7.3, 1. So now I would like for you to pause the video and do example number 2, and then we will come back and I will give you the answer to example number 2. In example number 2, the coordinates of our midpoint, xm, ym, we plug in our values, x1 plus x2 divided by 2, and y1 plus y2 divided by 2. And when we calculate this out, we can either write this as a fraction, negative 11 over 2, comma, negative 2, or we can write it as a decimal, negative 5.5, comma, negative 2. Hopefully you got that answer. Let's move on to finding the distance. So in example number 3, we are asked to find the distance between each pair of points with the given coordinates. So we are going to use the distance formula that you have at the top of your page. Distance equals the square root of x2 minus x1 quantity squared plus y2, which is, let's put in the value for y2 there. y2 is negative 5 minus 8 quantity squared. Now remember, when we have minus and negative, we could write that as add the opposite. So as we evaluate this, we get 2 squared plus negative 13 squared so the square root of 4 plus negative 13 squared is 169 equals the square root of 173. Many times we will ask you to leave this as an exact value, or sometimes you'll be asked to approximate a value with your calculator, which then we would get 13.15. Now I'm going to pause the video, and I would like for you to go over and work example number 4, and then I will come back and give you the correct answer. Okay, be sure to show your substitution. So show your setup from the beginning using the distance formula is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. When you evaluate that, you should get a final answer equal to 13. So hopefully you found that answer. Please show all your work and come to class on Wednesday with these notes complete and ready to find midpoint and distance formulas in class.